Okay, so section 9.6, variation. So this is just some terminology. So direct, positive variation, y varies directly as x. So if you see the term y varies directly as x, well, that just means y is equal to kx, where k is some constant, and this is called the constant of proportionality, or the constant of variation. So either one. The inverse, the negative variation. So if you see y varies inversely as x, or y varies negatively as x, then that just means that y is equal to k over x, where again k is the constant of proportionality, the constant of variation. Varies jointly, so joint variation. Joint variation is really the same as direct variation, but usually if we have more than one variable, rather than say direct, sometimes we'll say joint. And so z varies jointly as x and y. And so if you see the phrase z varies jointly as x and y, that means that z is equal to k times x times y, where k is some constant of proportionality. So let's do on page 390, let's say problem number 2. In exercises 1 through 20, write a complete statement of the function. And so the quantity y varies directly as the cube of x. Okay, so y varies directly as the cube of x. And so the cube of x is just x cubed. Since it varies directly, then there's some constant proportionality k such that y is equal to kx squared. Let me do problem number 6. The quantity c is inversely question cube cube. um so oh, I see. My C looks like an L. Okay, how's that? Cube. The quantity C varies proportional varies is inversely proportional to the square root of P. And so the quantity C is inversely proportional, so K over the square root of P, so square root of P. And so there's some constant, so C is equal to some constant proportionality K divided by the square root of P. Let me do problem number 12. The quantity P varies directly as a square of Q and inversely as the cube of R. And so the quantity P varies directly, so is equal to some constant proportionality K as the square of Q, so Q squared, and inversely, so divided by the cube of R cubed. And that's your answer. Problem number 20. The quantity P at the point P of xy varies inversely as the product of the distances of P from the coordinate axes. Okay, so if I look here, suppose I have some point P. Then the distance to the x-axis would be y. It's actually the absolute value of y. Distance to the x-axis would be the absolute value of x. Again, I don't know if x and y are positive. Therefore, P is equal to, so it varies inversely, so K over the product of the two distances. Well, the distances are x and y. Now, I don't need the absolute values because I can always absorb those signs into the constant proportionality K. So I'll just say P over K xy. Again, if you put in the absolute values, it wouldn't be wrong. It's just, it looks a little simpler without having the particular absolute values. Let me do problem number 22. Problem 22. In exercises 21 through 28, write a complete statement of the function and then use the given information to find the constant of variation. So P varies directly as the square of T, and P is equal to 10 when T is equal to 2. So let's do this. So P varies directly as the square of T. P is equal to 10 when T is equal to 2. 2 squared is 4. Divide both sides of my equation by 4. And so K is equal to 10 over 4, 5/2. Therefore, P is equal to 5/2 T squared. And that is your answer. So once I have solved for K, plug K back into my original equation, and then that gives me my complete statement for the function. Let me do problem number 26. S varies inversely as the square of R, and S is equal to 14 when R is equal to 3. Okay, so that says that S is equal to, since S varies inversely, then it's got to be K divided by the square of R, so R squared. Now, S is 14 when R is 3. And so 14 is equal to K over 9. Multiply both sides of my equation by 9. So K is equal to 126. Therefore, S is equal to K, 126 over R squared. And that is my complete statement. Let me do problem number 28. V varies jointly as the square of X and the cube of Y. V is equal to 12 when X is equal to 2 and Y is equal to 3. Okay, so I have here that V varies jointly as the square of X and the cube of Y. So V is equal to K, X squared, Y cubed. V is equal to 12 when X is equal to 2 and Y is equal to 3. So 12 is equal to K. 2 squared is 4. 3 cubed is 27. So 12 is equal to 108K. Divide both sides of your equation by 108. So K is equal to 108 divided by 12 is 9. So therefore, v is equal to 1/9 x squared y cubed. And that is your answer. Let me do problem number 30. Z is equal to k over x cubed. And exercises 19 through 42. No. In exercises 29 through 42. Determine whether the function represents direct, inverse, joint, variation, or none of these. And so, well, I'm dividing, therefore it's inverse negative variation. Let me do problem 32. P of t is equal to k t to the 4. Well, it's k times something, so it is direct variation. (34) I of x is equal to 4x plus 3. Well, you're not just multiplying and you're not just dividing. You're adding something. So none of these variation problems did we ever say you could add. And so this is none of the above. It is not a variation. It's an affine transformation. 36. L xy equals k x cubed y radical y. So in this case, well, it's direct variation, but actually I'll call it joint variation because, well, there's two variables, x and y, so I'll call it joint variation. But direct positive variation is also correct. 38. M of xy 2x squared y squared minus 7. Again, I'm subtracting 7, and you can't do that. That's not anything that I've seen, so that's none of these. It's not a variation problem. Let me do problem number, let's say 44. So according to Hooke's law, the force F exerted on a spring is directly proportional to the amount of stretch x of the spring if a force of 100 pounds stretches the spring by 8 inches. Find the amount. of stretch if the force is 75 pounds. Okay, so let's do that. So, but according to Hooke's law, the force is proportional to x. Okay, so we want to figure out what x is when F is 75. Okay, so we want to do that. So first off, I know that a force of 100 pounds stretches the spring 8 inches. Divide both sides of my equation by 8. So I get that K is equal to 12.5, 25 over 2. So the force is equal to K, 25 over 2x. I want to determine x when the force is 75. Multiply both sides of my equation by 2. So 150 equals 25x. Divide both sides of my equation by 25. And so x should equal 6. And so a 75 pound weight should stretch the spring 6 inches. Let me do problem number 48. Under constant pressure, the pressure, the volume, V of a gas is proportional is directly proportional to the temperature T if the gas occupies 80 cubic inches when the temperature is 90 degrees. At what temperature will the volume of the gas be 96 cubic inches? Okay. So you're expanding the gas, so the temperature should somehow rise. So let's see. The volume is directly proportional to the temperature. The gas occupies 80 cubic inches when the temperature is 90 degrees. divide both sides of my equation by 90. So K is equal to 8 over 9. So V equals K 8 over 9 T. So what's the temperature when the volume is 96 cubic inches? So let me multiply both sides of my equation by 9. Oops. And so 864 T. Divide both sides of my equation by 8. And so T is equal to 108. So we have that if your volume, if your gas is now 96 cubic inches, then the temperature is 108 degrees. No, it said at what temperature will the volume of the gas be 96? So it's 96. Okay. Let me do problem number 54. The electric resistance R in a cable is inversely proportional to the radius R, little r now, of the cable. So now we've got to be careful not to change the whether this is capital or lowercase. So we've got to be very careful with the case. If a cable with radius 0.25 inches exerts an electric resistance of 0.2 ohm, find the resistance of a cable with a radius of 0.7 inches. Give your answer correct to 3 decimal places. Okay, so let's do that. And so the resistance R is inversely proportional to the radius little r. And so I have that if the cable with radius 0.25 inches exerts an electric resistance of 0.2 ohm, let's figure out what K is. So let me multiply both sides of my equation by 0.25. And so I get 0.05 is K. So therefore R, capital R, is equal to K divided by little r. Okay, so find the resistance of cable with radius 0.7. Okay, so let's do that. So R is equal to 0.05 divided by 0.70. 5 divided by 70, so 70 divided by 5 is 14. So R is equal to 1 over 14 ohm. And I want to give this, I guess, so R 1 over 14, so that's 0.0714285, 714,285, and so ohm. And I want to write this correct to 3 decimal places, 0.071 ohm. And so that is your resistance. Let me do problem 58. The strength S of a rectangular wooden beam of given length varies jointly as the square of the width x and the depth y if a beam of width 3 inches and depth 5 inches has strength 250 pounds. Find the strength of a beam obviously the same type of beam of the same length and wood of width 4 inches and depth 6 inches. Okay, so the strength S varies jointly as the square of the width x and the depth y. Okay, good. So we have that if the width is 3 inches and the depth is 5 inches, then the strength is 250 pounds. Okay. Let me simplify that. So I have 250 is equal to K, 5 squared, 3 squared is 9, times 5 is 45. Divide both sides of my equation by 45. And so K is equal to 250 over 45. I can divide both 250 and 45 by 5. So 50 over 9. So therefore, S is equal to 50 over 9 x squared y. I want to figure out the strength, S, when x is 4, the width is 4, and the depth is 6. Okay, no, it's going to be in threes. So S is equal to 50 times 16 times 6 over 9. And so 50 times 6, 300 times 16, 4,800 over 9. And so I can divide both 4,809 by 3. So that's 1,600 over 3. And so the strength is 533 1/3 pounds. Let me do problem number 60. Oh. Describe what is meant by an inverse variation. And so, well, an inverse variation means that the product of the variables is constant. In other words, if I have, say, constants x and y, then the product of x and y is just k, or another way of saying this, y is equal to k over x. Okay. So that really finishes off section 9 point, what was it, 9.6? And so tomorrow, I guess at noon, we will be looking over the sample exam. Okay, so I guess I will see you guys tomorrow. Okay, and so let me get rid of everyone so that we can look at the tape of this. Bye-bye. See you tomorrow.